Hello there, this is a video for Algebra 2. It's Chapter 3, Section 5, Systems of Equations in 3 variables. And if you thought elimination was complicated with 2 variables, well, hold on to your chair. But this is like dirty, but this is like elimination on steroids. So, have no fear, I will show you how this works. But before we get to that, I wanted to show you something that I refuse to graph myself because it's just too crazy. And so in your textbook, on page, 161, if you care to look at it, you have a couple of diagrams. Why isn't it going away? Hold on. No? Okay, whatever. Sorry about that, but I can't show you all of it. But it's in your book, and basically we're talking about solutions. You know that when you have lines, equations of lines, there's no solution if the lines are parallel. There's one solution if the lines intersect, and then of course there's infinitely many solutions if they're the same line. Well, you can have a similar scenario happen with systems of 3 variables, but we have to look at it in 3 dimensions, which is why I didn't want to draw the graphs for you. But again, I am referencing page 161, and you can go there and look to see the different types of solutions you can have. You can have one solution when 3 planes intersect at a specific point, and that's kind of what's demonstrated here. You can have infinitely many solutions in 2 different ways, and so they show you how that works. And then you can have no solution if the 3 planes are parallel or if they never intersect all at the same time. So it's kind of dark and it's kind of hard to see here, but again, you want to make sure that you take a look at page 161 in your textbook. When you do solve, so we'll go back to our normal board here. And when you do solve a system of 3 variables, you have to keep in mind that your answer is going to be not an ordered pair, but an ordered triple, because it will have 3 variables, x, y, z, or a, b, c. And again, when you write the answer, you want to write it in alphabetical order. So if it's a, b, c, you want to put the a first, b second, c third. All right, so how do we do this then? Basically, what we have to do is break this down into smaller systems, okay? So what we're trying to do is we're going to take 2 equations at a time. You can't work with all 3 of them at the same time. So for example, I'm going to take these 2 equations first, and then my job is to try to eliminate a variable. I'm looking at the y variable here, negative 2y and positive y. So if I were to multiply the bottom equation by a positive 2, then that will yield me negative 8x minus 10z. Sorry, I forgot the y. Okay, so 2 times negative 4x is negative 8x, 2 times y is plus 2y, and then 2 times negative 5z is negative 10z, and then we'll get 2 times negative 36, and of course, because I'm lame, 2 times negative 36 is negative 72. So that's my new equation. If I take that equation and add it to the top equation, which is 3x minus 2y plus 4z equals 35, and combine those 2 just like I did in the past, then the y variable is going to cancel, and I'm going to get 3 minus 8, which is negative 5x, and 4 minus 10, which is negative 6z, and 35 minus 72, which is negative 37. And this is now an equation in only 2 variables. So now the goal is to do the same exact thing with using the next 2 equations. Okay? But the key here is, and I want to say this very clearly, I want you to understand, the key is once you have chosen to eliminate the y variable in the first 2 equations, then you have to eliminate the y variable in the next 2. If you decide to eliminate a different variable now, you're going to get all screwed up. So again, I already chose to get rid of the y the first time, so I have to get rid of y the second time. So I don't have a choice in which variable I'm going to choose. But again, I'm looking at my 2 equations. I've got a positive y and a negative 3y. So I'm going to multiply this equation this time by a 3, not a 2. And so 3 times negative 4x is negative 12x. 3 times positive y is plus 3y. 3 times negative 5 is negative 15z. And then 3 times negative 36, where's my calculator when you need it? Is right there. So if I multiply the second equation by 3, I get this here in red. And I'm now going to add that to this equation, which was 5x minus 3y plus 3z equals 31. And you're going to see right now why I keep calling this elimination on steroids. Negative 12 plus 5 is going to give you negative 7x. Negative 15 plus 3z, lost my little thing there, is going to be negative 12z. And negative 108 plus 31 is negative 77. So what I have created now, if you haven't noticed yet, is two equations that have the same two variables. I have an x and a z here and an x and a z there. So now what I'm going to do is take those two equations, negative 5x minus 6z equals 37 from before, and the negative 7x minus 12z equals negative 77 from here. And now I'm going to try to eliminate again. I'm going to eliminate a second variable. You can see why if you eliminate a different variable each time, you're not going to be able to get this. In order to get this situation, you have to eliminate the same variable in the first 2 times that you did it. So now I'm looking at this result, and I'm looking at the z's, because 6 and 12 are multiples of each other. So if I can take the top equation times a negative 2, then that will give me negative 5 times negative 2 is positive 10x. Negative 6 times negative 2 is positive 12z. And negative 2 times negative 37, or positive 37, sorry. Negative 2 times positive 37 is negative 74. And now if I add, this is now gone. I multiply by negative 2, and here it is. So now when I add these two equations together, 10x minus 7x is 3x. The z's are going to cancel. And negative 77 plus negative 74 is negative 151. Last step is to divide by 3. Well, I shouldn't say last step, but at least in this case. Negative 151 divided by 3 is some weird decimal. Let's see here. It doesn't even go evenly, so we're going to get negative 151 divided by 3. Let me check my little answer here. Blah, 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 blah. Something went wrong. That's not good. Let me check something. I'm pretty sure it's not supposed to be a fraction. So I'm going to make sure that that's not. I think I just saw my mistake here. Here I wrote negative 5x minus 6z equals negative 37. I'm not exactly sure what I wrote here because I can't see it anymore. But this should be a negative 37 times a negative 2. And that should be positive 74. And I think I had written down negative 74. So that's what went wrong there. So I apologize for that. We'll just fix this in here real quick. So actually you have negative 77 plus 74, and that gives you a negative 3, and that sounds more like it. And when you divide by 3, then x equals negative 1. And then we're halfway home. Well, we're 1/3 of the way home. We still need to find y and z. But we can get the z value by plugging in x to either one of these equations that you would like. So I'm going to do that right now. We're going to go with this guy, negative 5 times x minus 6z equals negative 37. And I'm going to replace the x with a negative 1. And so that's going to be positive 5 minus 6z equals negative 37. Subtract the 5 to both sides, and you get negative 6z equals negative 42. Divide by negative 6, and z should equal positive 7. All right, So once we get our z, now all that's left is to find y. And I'm running out of space already. But that should be the easiest of our troubles. We will go to the original equations. Let's see, where do I have space? I don't have any more space. Okay, I'm going to just come down here. 3x minus 2y plus 4z equals, it barely fits, 35. Okay, so there I am. And x was -1. And z is 7. And then we're going to keep simplifying. So we're going to get -3 minus 2y plus 4 times 7 is 28 equals 35. 28 minus 3 is 25. So we're going to subtract 25 from over here. And you get -2y equals 35 minus 25, which is 10. Divided by -2, we barely have space. And y equals -5. Awesome. So our last step is to write it out in an ordered triple. X coordinate goes first. Y coordinate goes second. And the z coordinate goes last. And believe it or not, that is how the cookie crumbles. I know what you're thinking. It's crazy. I know. You have to really keep track of what you're doing though. So we are now going to let you try a couple. Now you'll see that I left a lot of space here. There's a part B as well. But I need all the space on the board that I can use so when I go over with you in class. But there you go. And then we have this little guy. So we're going to do the exact same thing. What I want to show you with example 2 is that sometimes you can have no solution or you can have an infinite solution. So we're going to do that and show you kind of what that looks like. So again, our goal is to get 2 equations at a time. Not really sure that it matters who you pick at this point. There's no variable that has x or y or z by itself. So I'm just going to go with the first 2. And then we're going to say, let's see, what is the least common multiple before 4 and 10? 20? Yes, 20. So we are going to take the top equation and multiply it. I'm trying to eliminate the x's, I guess. So 5 times 4 will be 20. And the bottom equation times a 5, because 5 times -4 will be -20. So I'm trying to cancel out my x's. So 5 times 4 is going to give me 20x. 4 times 4 is plus 16y. 4 times -5 is -20z. Someone is checking my math, right? Okay, -40. Then here we get -4 times 5 is -20x. And then 5 times -10 is -50y. And then -40 zeta. And then equals, I don't know what's 16 times 5. I think it's 80, but I'm going to confirm 80, yes. Add these 2 together, and the x's are going to cancel. 16 minus 50 is -34y. 20 and 40 is -60z. And -120. Jess? Awesome. Okay. So, then we're going to do the second 2 equations and do the same thing. Remember that what I said earlier, I already chose to eliminate x in these 2 equations, so I have to eliminate the same variable in these 2 equations. So with -4 and 6, we're going to go with 12. So this time I'm going to multiply the second equation by a 3 to get a -12, and the bottom equation by a 2 to get a +12. So -4 times 3, -12x. 3 times -10, -30y. 3 times -8, -24z. And 16 times 3 is -48. And then we're going to do 2 times 6 is +12x. 2 times 15 is +30y. And 2 times 12 is 24z. and 2 times 24 is 48. Like this. And you can already see what just happened in this scenario is that 12 and negative 12 cancel, 30 and negative 30 cancel, 24 and negative 4 cancel, 48 minus 48 is 0. Everything under the sun canceled. However, this is completely true. 0 always equals 0. So this is a case where you have infinitely many solutions. So we can stop now. Isn't that good news? Because basically we have a situation where we got 0 equals 0. So infinitely many solutions. This is a case where either the planes are the same plane or the planes all intersect in one line. So there's infinitely many solutions. So that's part A. We want to do part B now. And y'all can leave behind the camera, please. And quietly, please. So, we're going to keep going here. We're almost done this. Example 2. I'm going to start all over again, do the same exact thing. We are going to try these first 2 equations. You guys need to exit quietly, please. And so with the first equation, I'm going to choose to eliminate the a variable. And so this is a negative 6, so I want to make this a positive 6. So negative 3 times negative 2 will be positive 6a, and that's to be negative 6a. So I'm going to go ahead and do that. Negative 3 times negative 2, positive 6a. Negative 3 times positive 3, negative 9b. Negative 3 times negative 4, positive 12c. And then negative 3 times 7 is negative 21. Above, I'm going to rewrite this equation just for my ease. I get negative 6a plus 9b minus 12c equals 21. And so this time, I'm going to cancel out my negative 6a with positive 6a, positive 9b with negative 9b, negative 12, positive 12, and 21 minus 21. And again, I'm going to get a situation where 0 equals 0. And so, but that doesn't mean necessarily that it's going to be like the one before. In the case before, remember, I can go back real quick. We ended up with an equation like this and a 0 equals 0. That combination made for this to be infinitely many solutions. But in the next example, we need to, before we get carried away and go straight to 0 equals 0, we need to still try to get rid of these next 2 equations first and see what happens. And I'll explain to you right now what I mean by that. Remember again that my goal was to get rid of a the first time around. So I'm going to try to get rid of a the second time around. So I'm going to take my second equation and multiply it by 5 this time, because 5 times negative 2 will give me negative 10a, and then I have a positive 10a. So 5 times positive 3 will be plus 15b, and then 5 times negative 4 will be negative 20c, and 5 times 7 will be 35. And it's almost like the previous one, but not exactly. So the a's will cancel, and then the b's also canceled, and the c's cancel, giving you a 0 on the left. But 30 and 35 do not cancel. 35 minus 3 is actually 5, and 0 does not equal 5. So this portion is never true. So even though that one was always true, this one is never true. That combination is going to give you a no solution. This is a case where the planes are parallel, or at least 2 of them are parallel. And that's why you can't find a solution. So again, don't assume that the first time that you eliminate with 2 equations that you're done. You have to do it twice and look at both results before you can determine whether it's a no solution or an infinitely many solutions. So you are now going to try this little guy. There's part A, there's part B, and I'm going to do one last example, which is a word problem for you. I know you guys don't like those, so I want to do that for you. And so here we go. It says, Miss Garza invested $50,000 in 3 different accounts. Okay, so basically we have to identify those accounts. So there's three different ones. I'm just going to call them X, Y, and Z. Okay, she invested 3 times as much money in an account that paid 8% interest. So one of our accounts is 8% interest. Then an account that paid 10% interest, so we have a 10% interest account. And then we have a 12% interest account. Okay, so X, Y, and Z basically represent the amount of money she invested in the 8% account. Y represents the amount of money she invested in the 10% account. And Z represents the amount of money she invested in the 12% account. So we can go back to the very first sentence, which says that she invested $50,000 combined. So the money from her X account and her Y account and her Z account should all add up to $50,000. Okay, that's the first equation. Then we know that she had, she earned a total of $5,160 in interest in a year. While interest is when you take the interest rate and multiply it by how much money you have. Since X is how much money I have and 8 is my interest rate, then I can go 0.08x plus 0.1y plus 0.12z equals 5160. Okay, so what I'm saying there is 8% times x, 10% times y, 12% times z should equal total interest earned of $5,106. So the only thing we haven't talked about here is this whole, she invested 3 times as much money in an account that paid 8% interest than in an account that paid 10% interest. So what that is telling us is that the 8% account is going to have 3 times as much money as the 10% account. That's saying she invested 3 times as much money in an account that paid 8%. So the 8% account is going to equal 3 times whatever she put in the 10% account. So that's where you get your x equals 3y. And so now we have all 3 of our equations. I will tell you that it is easier for us to multiply this second equation by 100 to get rid of all those decimals right off the bat. So I'm going to do that right away and put 8x up here plus 10y plus 12z and 516000. Okay, that's going to help us get rid of all of those crazy decimals. So I'm going to erase this decimal equation now. We don't need it anymore. And there I go. Okay, so the first thing I'm going to do is try to eliminate a variable. So I'm going to choose to eliminate x. It doesn't really matter. Any x, y, or z will work because they're all coefficient of 1. But I'm going to go ahead and just eliminate the x's by multiplying by -8. So that's going to give me negative 8x minus 8y minus 8z equal to negative 8 times 50,000 is negative 400,000. There we go. Okay, then I'm going to take, this is me multiplying the second equation by -8. Then I'm going to add it to the top equation, which is positive 8x, positive 10y, plus 12z equals 516000. When I add those two together, the x's are going to cancel, and I'll get 2y plus 4z equals 116,000. Okay? Now, the next thing I'm going to do is I'm going to take this x equals 3y, and I'm going to plug this. I'm not even going to use I'm not going to use elimination here. I'm actually going to use substitution to get rid of the x's between this second equation. So this is these two over there, and now I'm going to take these two equations and get rid of the x by replacing this x with 3y, substitution. Okay, so instead of x, I'm going to put 3y, and then there's plus y plus z equals 50,000. So that's 4y plus z equals 50,000. So what that means is that now I have two equations with y and z. But in order for me to cancel out another variable, I'm going to use elimination this time. So what I want to do is I want to get rid of the y's. This is a 4y, this is a 2y. So I'm going to multiply this by -2, which is going to give me -4y minus 8z, and 116,000 times -2 is going to be, let's see, -232,000, like that. And then I'm going to add to it this equation, which is positive 4y plus z equals 50,000, and we're almost done. The y's are going to now cancel. -8 plus 1 is -7z, and -232,000 plus 50,000 is -182,000. And when we divide that by -7, z actually equals 26,000. So we already know now that I have to, Ms. Garza needs to invest $26,000 into her 12% interest account. And then we can find y very easily by plugging our z value into any one of this equation or that equation. So I'm going to use this 2y plus 4z equals 116k. Okay, I'm running out of space. And since z equals 26,000, I'm going to say 2y plus 4 times 26,000 is going to equal, I don't know, a big number. 4 times 26,000 is going to equal 104,000. So I'm going to take the 116,000 and subtract the 104,000, and now we're going to get 2y equals 12,000, divide by 2, and then y equals 6,000. So Ms. Garza needs to invest 6,000 in the 10% account. And then the last one is the easiest one. We already know that to solve for x, it's right over here. X equals 3 times y, and y was 6,000. So 3 times 6,000 means that x equals 18,000. So there you go. How much did she invest in each account? She invested 18,000 in an 8% account. She invested 6,000 in the 10% account, and she invested 26,000 in the 12% account. And that is how you do that. And again, like the last lesson, I did not give you a do-it-yourself question for example 3, but I wanted you to have that so you will be able to do your homework. So once you have completed the notes, the do-it-yourself questions for this lesson, you will have completed your notes for this lesson, and then I will see you in class, and thank you for watching.